In this video, let's look at the 2D case of Newton's second law. Let's draw a block, and now this is looking at it from the top, so this is a horizontal plane. Let's have a force F1 pointing to the right and it's pulling, and F2 pointing upwards, and this case looks like it's pushing that object. Alright, so as always, let's choose our coordinate system. Right is positive x and up is positive y. Let's say F1 is 4 newtons along positive x, as we can see here. F2 is 4 newtons along positive y, again as we can see here. Let's take the mass to be square root of 2 kilograms. Why this weird number? We will find out soon. And now we want to find out the acceleration of this object. And see, the acceleration is a vector, so we need to tell the magnitude and the direction of this acceleration. Now we can do it in two ways. You can find the net or the resultant force, then apply Newton's second law to get the acceleration, or we can get the x and y components of the acceleration and then use Pythagorean theorem to get the net acceleration. So let's do it both ways. But before we start, let's look at a big concept called free body diagrams, or FBD for short. And what this is it isolates the object of which the acceleration we are trying to find and puts in all the forces on that object. That makes it easier to solve these problems and causes a lot less confusion. So the first trick about drawing a free body diagram is you replace the object, no matter what shape or size or anything, you replace the object by a big dot. Right? So now this is the object. Then you draw all the forces on this object, preserving the lengths of the arrows if the lengths of the arrows are given, and the directions of the forces. So F1 points to the right, so this is F1, always label it, and all the forces should originate at that dot. So even though F2 seems to be pushing that object, for our free body diagram, F2 force will originate at that dot. And now we can easily find the net force using the component method. And so the resultant is going to be, in this case, F net. And so we now know that the acceleration is also going to point in the same direction as the F net. Alright, so let's take a look at how to solve this. We know that F1 is 4 newtons and F2 is also 4 newtons. So we use Pythagorean theorem to find out what the magnitude of F net is, and that will be the square root of F1 squared plus F2 squared, which is square root of 4 squared plus 4 squared, which is 4 square root of 2. How about the direction? If we call this angle theta, theta is tangent inverse of F2 over F1, and since it's both are the same, tangent inverse of 1, that is 45 degrees, so we know that the force acts 45 degrees above the x-axis, and the magnitude is 4 square root of 2. So using Newton's second law, F net is mass times acceleration net. So this is 4 square root of 2. The mass is square root of 2 kilograms and the net acceleration. So now dividing both sides by square root of 2, we finally end up with the net acceleration is equal to 4 meters per second squared. Alright, so that is one way of doing it. The other way of doing it is using sum of all forces in the x direction and the sum of all forces in the y direction. So let's do it that way also. Alright, let's do sum of all forces in the x direction, and in this case there is only F1 which points in the x direction, and that is equal to mass times acceleration in the x direction. So now F1 is 4, the mass is square root of 2, and acceleration in the x direction ax. And so this tells us that ax is 4 divided by square root of 2 meters per second squared. So this is not the net acceleration, but only the component of the net acceleration in the x direction ax. Let's do the same thing in the y direction. Sum of all forces in the y direction. In this case, there is only F2, which is in the y direction. Again, remember that F2 is up and up is positive. And similarly, in the earlier one, F1 was positive because it was pointing to the right, and x is positive to the right. So sum of all forces in the y direction, and that is equal to mass times acceleration in the y direction. F2 is again 4 newtons, mass is square root of 2 kilograms, AY, and that tells us AY is again 4 over square root of 2 meters per second squared. Now we need to find the net acceleration. So the net acceleration is the square root of ax squared plus ay squared. And so now this is square root of 4 over square root of 2 squared plus the same with the y direction. Now this is equal to 16 over 2 plus 16 over 2, which is square root of 32 over 2, which is square root of 16, which is 4 meters per second squared. And as we can see, the answer is the same. So now we still need to find the direction of this net acceleration, and the direction theta is going to be tangent inverse of ay over ax, which is again tangent inverse of 4 over square root of 2 divided by 4 over square root of 2, so tangent inverse of 1, which is again 45 degrees. That's the same value in both cases. Alright, so this is how you would do a two-dimensional problem. It's again the same thing. All you need is vectors, and as long as you do your vector addition correctly and resolve along the x and y directions correctly, you should be able to do any Newton's second law problems using this rubric.